Hi, I'm Kirsch, and I'm going to be covering one of the most critical features of any flyback converter or power switching converter, and that is how far do you isolate the switching node from the rest of the traces. You can do that using constraint rules and constraint management in your software. In today's lesson, I'm going to show you how to do that in Allegro X. So follow along with me in Allegro X Venture so I could show you how to do creepage and clearance rules to make sure you keep your EMI traces away from your other traces on your flyback. Before we get started, make sure you're using the Allegro X Venture license. You want to make sure it's at the top bar of your PCB editor software or your PCB editor tool. It says Allegro X Venture at the top. Now, question is, why would we define clearance or creepage on a PCB in the software? Well, when you're fabricating the PCB and it's made and you're hand soldering components and everything, due to physical reasons, moisture in the air, and a number of different things related to the printed circuit board, you could end up shorting the PCB. You can get arcs, contamination, hand soldering mistakes that can all cause issues. So instead, what we're going to do is bake it into the design itself according to whatever your standard is. I'll be using some example spacing. So here I'm going to go into the constraint manager so you can see what options we have for clearance and creepage. Go to setup, and underneath constraints, you have constraint modes. Under design, you have creepage and clearance options. When I hover over it, it shows me and explains what clearance pollution degrees we're dealing with according to groove level. So you have pollution degrees 1 through 4, the X values and whatnot. Now here you can set certain values. Let's say 6 millimeters. I'm just putting that arbitrary number in there, and you hit enter and then click apply. Then it will do that regardless of what measurements or units of measurement you're in. So it can automatically change to mils. With that set, we can go into our setup and constraints. Then under physical, you can set specific conductors or net classes to have groups of conductors. So for instance, I have a net class for power. I have a net class for the hot loop. Anything under hot loop, I'm going to want to include under power to have a certain minimum trace width so I can reduce my impedance and inductance. Yes, but this can also be a member of an electrical constraint or group for high voltage. So if I go to electrical, go to creepage and clearance, I right click and then create high voltage constraint set. Then the creepage, I could say 6 millimeters. Clearance could be 6.5 millimeters. Then I can go down into the nets and start assigning this high voltage creepage clearance rule to any of my traces. So if I go down to high voltage creepage and clearance, I have this hot loop. I want it to have the HVS1. So any member of the hot loop group, I want to ensure is far enough away from other nets. So now that I've set the creepage and clearance rules in the constraint manager, I've intentionally set up this design, this layout, to violate these rules. Let me show you how this works and the different ways you can double check if you are violating clearance and creepage in Allegro. We can see that when the clearance and creepage rules are applied to the hot loop, we have the DRC, the design rule check. Net name hot loop is line to SMD spacing, constraint value 236 mils, which is 6 millimeters. Actual value, you're closer than that essentially. Okay, let me give you another example. So if I were to slide this out, let's see if I slide this out, see it's complaining that it's too close. If I move this out the way, that via doesn't have those DRC errors anymore, right? So basically it's saying, oh yeah, everything is just too close to this. If I move this trace via, that is no longer in clearance violation. Matter of fact, I would need to take this entire device or component, move it over somewhere else, let's say over there, and then that violation disappears. Then there's another really cool thing you can do. This is in the workflow. This is the Vision Manager. I really like this. So if you go to View Vision Manager, you get to set your vision to be creepage and clearance vision. Now you can look at what meets creepage versus clearance. That's going to be highlighted in green. Boom, right? You can tell at a glance. What violates creepage and clearance. It will show you the violations for that. So if I dim my background and turn them all on, it shows what's violating, what meets the creepage and clearance, and what violates clearance and creepage separately. Depending on your situation, you may need to place, so for example, you can place a rectangle, board geometry cutout, and then you can draw a rectangle, set your trim and your rounding, then draw a slot. That would help increase the space between any of your objects. So let's say you needed to increase creepage, like clearance was good, but you needed to increase the creepage around, like between, for example, say this component and this trace, then you could do that with a slot. And here's what I like. After you change the rule there, right? Let's say you wanted to increase it to 8 millimeters, it updates immediately and automatically. That's why we encode this in the constraints and not eyeball it by just adding slots without the constraint. Now, I want you to see the difference between Allegro X and OrCAD X. In OrCAD, which is what I have this license in, it does not have the clearance and creepage option. You don't get that in OrCAD. So you'd have to use other methods like spacing in general or same net spacing, along with keep outs, slots you could put into the PCB. But at that point, you're kind of eyeballing it for the clearance and creepage. So that's all I wanted to show you. We split the board into their primary and secondary sides, added a slot for increasing the creepage, and most importantly, that design rule in Allegro so you can catch those violations early and not on the test bench. I'm Kirsch, and I'll see you in the next one.